Okay, all right, this is lesson 8 on multiples and factors. On page 141 and 142, read that with your family, and this will help you learn more about what we are getting ready to learn with multiples and factors. All right, students, get your math book out. You're going to turn to page 143. Please remember, if I write it, you write it. So make sure that you are writing down the things that I write down. If you have not already, please make sure that you look over the pictures I have attached to this assignment about multiples and factors. It will really help you when we get into this. All right, page 143. A garden has several rows of pumpkin plants. Each row has 10 plants. How many pumpkin plants could be in the garden? Okay, so the first thing we want to ask ourselves is, what is this problem about? Well, it's about rows, and not just any rows, but a garden that has rows with some pumpkin plants. So that's what this problem is about. What information is important? Well, it's important to know that each row has 10 plants, and what are we trying to find out? We are trying to find out how many pumpkin plants could be in the garden. Can I draw a model to solve this problem? Yes, I can. So we're going to draw a model to help us here. So it doesn't tell us how many plants are in each row. It just tells us that, it tells us that we have 10 plants in each row, but it does not tell us how many rows of plants we have. So we're going to draw 10 plants. So there's 10. I'm going to do another row. I'm going to do one more row. Now, if it was a garden, these rows would probably be a lot straighter than this, but that's all right. So we're going to say if I have 10 plants in each row, and I'm going to make 3 rows, that means I would have 30 plants here. Now, this is only one possibility. There are other possibilities. So we could have 5 rows. There could be 10 rows. It doesn't tell us how many rows. It just tells us how many are in each row. So we could also possibly have, so if we had 5 rows, it would be like 5 times 10 plants. So 5 rows times 10 plants in each row, and it would be 50 plants. So there's lots of different possibilities with the way that this problem is written. Go ahead and turn to page 144 in your math book. Okay, how can you describe how many pumpkin plants there could be? Well, there could be any number you get when you count by tens. So it's almost like skip counting, or you can also multiply by 10, because we know that there's 10 plants in each row. So no matter what number I use, as long as I am skip counting by 10 or multiplying by 10, that is how many plants would be in that pumpkin patch. So these are some important vocabulary words that we're going to need to know. This says you can extend your thinking about multiplication by looking at factors of a number. This is really important to know. Factor pairs, which you see right here, multiples, prime numbers, and composite numbers. So these are all very important vocabulary words that we're going to need for this math lesson. So first of all, a factor pair is two numbers that are multiplied to give a product. So 1 times 20 equals 20. So that is the factor pair of 1 times 20 equals 20 would be 20 is and blank. So it would be 20 is 1 and 20 because 1 times 20 equals 20. So there's other factor pairs of 22. 4 times 5 equals 20. So the factor pair would be 4 and 5. 2 times 10 equals 20. So the factor pair would be 2 and 10. So a factor pair is the two numbers that you multiply together. It's the two numbers you multiply to get an answer, okay? Or to get a product. Product is also another important math word. So if I multiply 4 times 5, that would be my factor pairs, 4 and 5. So we just came up with 6 different factors for 20. We came up with 1 and 20. We came up with 4 and 5. And we came up with 2 and 10. So I wrote it in like this right here because that's the order that we did it. But after you find these factor pairs, the way you should actually write these is in the correct order, like if you were counting. So if I was counting, the first number that I would get would be 1. And then I would get 2. Then I would get 4. Then I would get 5, followed by 10, and then 20. So if I connect these like a rainbow, if I had different colors here and I connected them like a rainbow, 1 times 20 is 20. 2 times 10 is 20. And then 4 times 5 is 20. Isn't that neat how you can make a rainbow out of the factor pairs? So now that we've learned about factor pairs, let's learn about a multiple. A multiple is a very important word too. A multiple is the product of a given number and any other whole number. So when you multiply numbers, the product is a multiple of each factor. So 20 is a multiple of its 6 factors. The number 20 is a multiple of 1, 2, 4, 5, 10, and 20. So pretty much a multiple is pretty much like the answer. So product is a fancy word for answer. And multiple, 20 is a multiple of 1. Because if I take 1 times something, I can get 20. If I take 2 times something, I can get 20. If I take 3 times something, can I get 20? Can you skip count by 3s and get 20? 3, 6, 9, 12, 15, 18, 21. So I skipped over it. So 3 is not a multiple of 20 because I cannot skip count and get it. But I can skip count by 2s to get to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So if I multiply 2 by 10, it's kind of hard to see, then I get 20. If I multiply 1 times 20, then I can get 20. So you have to be able to, each one of these numbers here, I can multiply by something and get the number 20. That's what makes them multiples of 20. Okay, next one. Our next two words are composite number and prime number. A number with more than one factor pair is called a composite number. So up here, where 20 had 1, 2, 3 factor pairs, that means 20 is a composite number. But a prime number has only one factor pair, the number and itself. That means take 3, the number 3 for instance. What times what equals 3? Well, 1 times 3 equals 3. Is there anything else that I can do something times something to get 3? Can I do 2? No. Can I do 4? No. This is the only way. So 3 is a prime number because that is the only way I can get 3. Whereas 20, I can do 1 times 20. I can do 2 times 10. I can do 4 times 5. So because I can do 3 different ways to get 20, 20 is a composite number. So that is how you tell the difference between prime and composite. Prime, you only have one factor pair. Composite, you have more than one. So you have 2 or more factor pairs. This is also very important. The number 1 is neither prime nor composite. You can see here, it's neither prime or composite. That's very, very important to remember. And that's just a fact you have to remember. There's no trick to remembering it. There is only one way to put 11 pumpkins in equal rows. Is 11 a prime number or a composite number? So if you take the number 11, you always have 1 times itself. So you always have 1 times 11. Can you do anything else to get 11? Think about that for a second. Okay, you cannot do 20, you cannot do 11 times anything else to get 11. So does that make it a prime number or a composite number? It makes it a prime number because you only can multiply it by one thing. 1 times 11. Okay? And our last one on this page, it says reflect. How is 20 a multiple of 5? Explain using multiplication and skip counting. Well, 20 is the product. And what's product? It's a fancy way to say answer of 4 and 5. Or you could say 4 times 5 equals 20. Also, if you skip count by 5s, you can get to 20. 0, 5, 10, 15, 20. That is how you know that 5 is a multiple of 20. All right, students, go ahead and turn to page 145 in your math book. All right, here we have, you see here, our important vocabulary words. The only one on here that I still feel like is important is product. So go ahead and add product to the bottom because that's something that you really need to know. It is going to be used a lot in 4th grade math and in every math as you get older. So our first word today is factor pair. So a factor pair is two numbers that are multiplied together to get a product. So an example would be 2 times 4 equals 8. So 2 and 4 are a factor pair of 8. Okay, our next one is multiple. A multiple is the product of a given number and any other whole number. So an example would be 4, 8, 12, and so on are multiples of 4. All right, next one, prime number. A prime number is a whole number that has only one factor pair, which would be 1 and itself, which means the number that's given. An example of this would be the number 7 is a prime number since its only factors are 1 and 7. Composite number. This is a number that has more than one factor pair. For example, 1 times 6 equals 6, and 2 times 3 equals 6. So 6 is composite. Last one, product. The answer to a problem. So let's do 4 times 5 equals 20. 20 is the product. Okay. I highly, highly recommend that you get some note cards and you write these 5 words down on a note card with their definition and their example, so that way you have them to refer back to and look at. It would really help you. Okay, let's take a look at number 2. Is 9 a prime number or a composite number? Explain. So I'm going to take the number 9 and I'm going to make kind of like a T-chart, okay? And this is how I like to figure out how many factor pairs the number 9 has. Because if you can find the factor pairs for a number, then you can determine if it's a prime number or a composite number, okay? So we always can have 1 as part of our factor pairs, because you can always do 1 times itself, because that's what would give us a prime number. So you always start with 1, and you can do 1 and 9. Now, can I do 2 times anything to get 9? 2, 4, 6, 8, 10. No. Can I do 3 times anything to get 9? 3, 6, 9. So yes, I can. So 3 times 3 would be a factor pair. Now, if you get to where this number right here matches that number, that means that's as far as you can go. You should not go any further. If you get to where, like, say this would be a 4 and that would be a 5, you cannot go any further. The only way you can go further is if there's numbers on a number line between those 2 numbers. So when we ask about the number 9, we would say that it is composite. And our explanation is that 9 has 2 factor pairs. It has 1 and 9, 3 and 3. So those are its 2 factor pairs. Go ahead and turn to page 146. Okay, 146. A park has several rows of trees. Each row has 5 trees. How many trees could be in the park? What is this problem about? Well, it's about a park that has rows of trees in it. Okay. What information is important? Well, it's important to know that each row has 5 trees. What am I trying to find out? I'm trying to find out how many trees could be in the park. Can I draw a model to help me solve this? Yes, I can draw a model. Okay. So I'm going to start with drawing just a row of 5 trees. Okay, there's my row of 5 trees. Now, it doesn't tell us how many rows there are. That means we get to choose the number of rows. So I'm going to pick 5 rows. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've got 5 rows, and there's 5 trees in each row. So if I am using this as my example, then this would be a 5 times 5, because it would be 5 rows and 5 trees. So my answer would be 25 trees. So anything that is a multiple of 5 could be our answer. Then down here on this one, we could also have 4 rows, right? If we had 4 rows, it would be 4 rows times 5 trees. So it would be 4 times 5 equals 20 trees. So there's several different options. Anything that you do times 5 is going to be a correct answer on this type of problem, because that is how these work. That is it for session 1. I will see you back for session 2.